Today we are covering the last lesson of chapter 4, 4.6 and 4.8, which is direct variation. Direct variation means that we have two variables that there is a same direction that they're going in, right? Direct for direction. So meaning if x is getting larger, then y is also getting larger. If x is getting smaller, then y is getting smaller. Right? So again, direct meaning same direction. Okay. So the equation is going to be something like y, the sentence is going to be y varies directly with x. We'll give you this equation right here, y equals kx. Well, solving for k, we get k equals y over x. So what we're going to do is plug y into the top, plug our x value into the bottom, divide or simplify, and then that will be our k value. If it asks for an equation of variation, we're going to take that value we get, plug it right in and say y equals that number of x. The first question, find the constant of variation of this k when given y varies directly with x. So again, y varies directly with x means this, and more specifically it means k is y over x. So in this first example, when y is 12, x is 6. So y is 12, x, this one down here is 6. 12 divided by 6 is 2. So k is 2. Continuing, same idea over here. K equals y over x. When y is 32, x is 4. So 32 divided by 4, 8 is k. Next, when y is 2, x is 10. So plugging it in. Now, 2 divided by 10 doesn't give you a nice number. However, we can simplify, right? Either using the calculator with the simplify button, the ABC button, or just dividing both top and bottom by 2, we get 1/5 is k. Next one on the slide here, k equals y over x. Y is 35 when x is 5, right? Y on top, x on the bottom, and we get 7 for k. And that's it. That's kind of the pattern we are continuing in this lesson. Now notice the directions change. Y varies directly with x. Okay, that stayed the same. Now it says use the values to write an equation of variation. We're doing the same thing we did last slide, but our final answer is going to look like this. Y equals 4x. Y equals half x, right? We're plugging k in. So again, reminder, k is y over x. Y is 8 when x is 4. So I get 2 for my k value. Now we're not done because this is not an equation of variation. We're going to take this 2, plug it right back in where that k is. So y equals 2x is our final answer. Next, same idea, k equals y over x. This time x is 16, y is 2. They kind of flip the order on us, giving us x first. And we get 1/8 is our k value. So when I write my sentence, y equals blank x, we're plugging in k where it was before. So y equals 1/8 x. Last one on the slide, k equals y, which is 28, over x, which is 7, right? Following the same pattern. We fill it in, we get 28 divided by 7 is 4 is my k value. And then I need my answer to look like this, so y equals 4x. And that is it for what you're doing, right? Just do your y divided by x to find k, plug it back in. And if you need more time to write notes, feel free to pause this video or check the notes filled in on Google Classroom. We've got a couple more examples before moving on to 4.8's lesson. We've got x is 6 when y is 54, and again, same direction. We're going to have k equals y over x, and our final answer should look like y equals some number where it's k, x. So k equals 54 over 6, and y is 54, x is 6. and I get 9, k equals 9. So my final answer is going to be y equals 9x. Go ahead and try the next two on your own and see how you do. So if you've got y equals 1/7 x on the next one, that's correct. Again, both 3 and 21 are divisible by 3. If you need to use the fraction button on your calculator for that, that's fine. Or you could simplify. And then the last one, we get y equals 6x. Then k is 48/8, which is 6. And then we plug it right back in. The next lesson is something we should be a little familiar with from an earlier chapter. In chapter 1, we talked about a function is for each x value, there's only one y, right? It wouldn't make sense if, say, I told you x is 3, and then for some reason, after we plugged it in, we've got two answers of 9 and +9 and -9, right? You wouldn't know which y value to give me, right? We have to say both. But basically, if that was a situation that was true, that would not be a function, right? A function is for each x value, there's only one y value, right? There's different forms these can take. Last time we looked at these, they were in tables where we were worried about, does the x repeat, right? It's kind of the same question we're looking at today. However, we'll also deal with some where they might be in pairs of points, or they might be a graph, or we could call it function bubble, where we've got one set of inputs go to another set of outputs. And it's just all different ways we can look at a function in different forms. Now we're adding two key pieces today. The domain is all inputs, right? And in this case, we're talking about specifically x value. So domain is all the x values. Now, if I told someone to write out the domain, you would not repeat if something was used twice. So if for some reason they put in there 2, 1, 2, 1 twice, you wouldn't write 2 2s in there. X only would appear in there 1 for number. Range is the other side of thing. It is our y value. So range is the y, domain is the x. And let's see what these problems look like for this lesson. Now, all the equations and functions in this lesson are going to be decide or determine whether the given information is a function. If it is yes, if it is a function, we're going to write the domain and range on it. If it is not, you're just going to say no. So we've done these before in tables, and again, we're looking for a red flag. A red flag is going to be a repeating x value. So I'm looking at my x's, and I see 0, 1, 2, 3. There was no repeat, so the alarm didn't go off, and it is, yes, a function. Now that it's a function, I'm going to write D for domain, and I'm going to write all these x values that have arrows up here. So I'm going to rewrite 0, 1, 2, 3, separated by commas, and that's my domain. My range, symbolized by an R value, is just going to be all y's without repeating. So I've got 2, 4, 6, and 8. Next one is x is 3, 5, 6, up. We've got an alarm going off. I've got 2 3s. Because I have 2 3s and our y values are different, this is not a function. So that's going to be a no. And then that problem is done. Next one, we've got x is -1, 2, 4, 7. Up, alarm did not go off, so that's a yes. And the domain is those same numbers I just mentioned. -1, 2, 4, 7. Again, basically go down this and don't repeat if there's a repeat. Range follows the same exact rule. We're going to go down this list and not repeat. I've got 3. 3, I already have a 3, so we're just skipping that one. 5. And another 5. So really, my range is only the numbers 3 and 5, right? Because they repeated, I don't need to write them a second time. So we've got 3 more of these. try the same thing. We'll do one more together and we'll see if you can get the next two on your own. I'm looking 5, 4, 3, 4. I've got an alarm going off here because there's two 4s. That makes it not a function. And looking for that red flag of an x repeating, and my y values were different. So not a function, so I don't need to write the domain and range. Now go ahead and try the next two on your own. Now going through them. 1, 3, negative 3. Oh, are they different? Yes, the negative makes it different. 5. So that one has no alarms. So now when I'm writing my domain, I do need to rewrite 1, 3, negative 3, and 5. And for my range, I'm going down the other side. 2, negative 2, 4, and 6. And separated by commas. And the last one, same idea. 8, 5, 2, 1. No red flag, so yes, it's a function. Writing 8, 5, 2, and 1 as my domain, hence the D. And R is range is 1, 3, 5, and 5 repeats. So I do not write it a second time. I just need to write a 1, 5 there. And that is how you do relation as a function or not with these graphs. Next, we're moving on to the bubbles. So what these bubbles say is this one's the input, so this is the x values, and the output is the y values, or domain and range. Right? Now, what we are looking for is we're looking for either an input that doesn't belong to an output, or we are looking for a input, an x value that has two arrows coming from it. My graph's a little off here. This 4 is supposed to be scooted up, and the 7 is supposed to be scooted up. There we go. That's a little better now. But this is the same as if we had the point 3, 5. When x is 3, y is 5. This arrow is when x is 4, y is 2, and this one is when x is 7, y is 8. And again, looking at those in table or point form, my x's don't repeat. So this one is yes, it's a function. Right? And domain is a little bit simpler here. You're just taking what's in the input box. So I have 3, 4, and 7 in the input box. Range is the output box. Again, you just list them once each, 2, 5, and 8. Now, the next one is, again, another example where my numbers are a little scooched off where they're supposed to be. But we have 1, 3, 5, 7. And here's the red flag right here. There's two arrows leaving 3. Again, what that is showing is that 3, 2 is a point and 3, 4 is a point. Right? In our table, that would have been a red flag. Oh, repeating 3s, therefore it's not going to work. So same idea here. We have a repeat. No, right? Is going to be the answer. A red flag went off. It's not a function. Because if I told you x equals 3, you'd have two different y answers you could give me. So therefore, it's not a function. We've got a couple more examples of this before we move on to graphs for the final bit. And we've got 7, 9, and 11. And then we've got 2, 4, 8, 1, 3, 4, 7, right? So do we have more than one arrow leaving? Right, there's a situation where we have more than one arrow leaving 11, so that is not a function. And then we're done, right? We don't have to write domain or range because we're done at that one. But the next one, one arrow, one arrow, one arrow, one arrow. So this one is great. Yes, it works, and our domain is 2, 4, 8, and 10. Now someone might ask, what about 3 here? 3's got 2 arrows. And again, what's the issue with things being a function? We can't have repeating x's, right? Each x has only one y. It is not that each y only belongs to one x. So this is okay for us to have 4, 3, and 10, 3 be a point because the x's don't repeat. Now, because of that, our range is just going to be 1, 3, and 5. Right? We only have 3 numbers here. And that wraps up the bubble side of things. So the last one we have left here are the graphs. And the graphs go by a rule of the vertical line test. And again, a vertical line is straight up and down. Now again, based on what we talked about, what would break this test? Right, so I'm going to put an example in here where what if we had the point 2, 2 and 2, 5, right? That would break this as a function because we're running into more than one point with that vertical line. So what the vertical line is doing is checking to make sure we're only going through one point at a time. We'll kind of color our line here blue. And if I'm going through more than one point on this graph at a time, it's not a function. This first one, no problem. I just went through everything once, and we're solid. So this one is yes. It's a function because we didn't run into an alarm. This next one, so far so good, no problem. Oh, we've got a gap, but that's not an issue. It's an issue to run into 2 points, not to have 0 points. So this one's also a yes. It's a function, right? What about our ones that don't work here? We got a couple examples here of ones that don't work. And now again, getting my blue line out. Right here is an example, and I'm running into more than one point, right? When I run into more than one point, that one's not a function, alarm goes off. And then over here, same idea, we're fine right here, but as soon as we move in, I've got 2 points, 2 points, right? So we've got 2 points in a lot of spots. Right? When x is -1, we've got 2 different values. So that one's also not a function. And that wraps up this lesson. Check on Google Classroom for your homework assignment.